we're definitely going into a global cooling cycle.
My guest today is David Dilley.
Thank you again for having me on, Tom. It's been great doing your podcast, and we're getting good information out to everyone around the world. I'm a former meteorologist of the National Weather Service here in the United States, and also the United States Air Force. Senior researcher, climatologist, meteorologist, Global Weather Oscillations Incorporated. And I have 50 years of experience. And I've developed what I call ClimatePulse Technology. This is for tracking the climate cycles, and predictions into the future. And it's all based on the proven science, the Milankovitch cycles. It is proven science. It's the electromagnetic interactions between the Earth, Moon, and Sun. And here at Global Weather, we specialize in hurricane landfall predictions. We're one of the very few companies that predict hurricane landfalls where they will landfall months in advance. And of course, El Nino, climate change, and we have many videos online. And beginning today, this is what we have. Climate change. Is it based on proven science or political science? Political science is what we're seeing in the media, all through the media. So which is it? Is political science proven science? Well, the global warming alarm sounded in 1998. The famous hockey stick. Everyone's heard of that. What this was a graphic done by Dr. Michael Mann, professor of Earth Environmental Science at the University of Pennsylvania in the United States of America. And the hockey stick, the reason it's called a hockey stick, is he recreated the temperatures in the United States going back to 1000 AD. That's a 1,000-year period. And the gray lines are part of a reconstruction where temperatures were higher or temperatures were lower. So they did the mean value of the temperatures. And what they showed was right around, starting 1000 AD, they just showed it was temperatures were going down slightly during the past 1,000 years. Then in 1902 is when they first started to record temperatures. And what happened? Look, that's the hockey stick. The temperatures went up, 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 up. So essentially what the hockey stick is showing is we've only had one global warming cycle. Started in 1902, according to Dr. Mann. And we never had a global warming cycle prior to that. And the problem on this, a big issue is when something hits the news, and this did hit the news big time, it sounded the alarm in climate change, and it went worldwide. And when you get a news item, that sticks in your mind, the very first article that comes out, or a big news item. So this sticks in people's minds. So they only go back to 1850. Most people don't even know what happened prior to 1850 because the media will not talk about it. But we're going to talk about it today. The hockey stick. Well, how did it work out? How did this hockey stick graph work out? And what we know today. Well, other science. This is the tree ring data and ice core data from the Antarctic and Greenland. This is done by Source Beck in 2007. So this is after the hockey stick. And what we see is we have had, this is going back to 800 AD. We see a global warming cycle, number one, when it cools down, global cooling cycle. Global warming cycle number 2, 3, 4, 5, 6. There's no hockey stick. Global warming cycles are natural and reoccurring. And Mann et al., one problem is they didn't use the period 800 to 1000 AD. So I don't know if they didn't want you to see the warming period back then, so they could create their hockey stick, but they have worked on their models since then, and the models are better. The trouble is, the world media has it entrenched in their mind, the hockey stick that was first put out. So there's our 6 global warming cycles. This is on the right, number 6, very warm, just as warm, or not even as warm as 1,000 years ago. And people do not know this. So we have had 6 global warming cycles during the past 1,200 years, not just one. We've had 6. During the past 8,000 years, we have probably had 80 climate change cycles. 80, not one, but 80 of global warming, global cooling. And this is what global warming, global cooling is. When a global cooling warming cycle begins, and they come about every 200 to 240 years, what happens is the high Arctic and then the Arctic begins to warm up. And as it warms up, then there's less cool air to come down into the mid-latitudes. So the mid-latitudes warm up. And that's where we are today. Warm mid-latitudes, global warming. We're right at the tail end of it. And when it does end, we go to global cooling. This also comes every 200 to 240 years. What happens is the high Arctic begins to cool down, and then the whole Arctic begins to cool down, and this eventually filters down into the mid-latitudes, and the mid-latitudes cool off, and we are in a global cooling cycle. And we're beginning to see this happen now. Well, in 2007, former United States Vice President Al Gore, he's very famous around the world, he won the Nobel Prize in conjunction with the IPCC, which is the Intergovernmental Panel on Climate Change. And the reason he won it, one reason is he quoted Professor Wazlowski by saying that the Arctic summer ice will be essentially gone in the year 2014 or 2015. The winter ice in the Arctic will be essentially gone around 2030. This made worldwide news. And how did that work out? Well, here's the Arctic ice now, Arctic sea ice extent. Right here is as of November 9th, the year 2023, which is right now, pretty much. It's the line right where the black line right here where the red line ends. The blue line is the mean Arctic ice during the period 1991 to 2000. And we're just about at that. That's more ice. Now, everything below that, you can see about 7-8 years or so or more, is less ice extent. So here we are in the year 2023. The high Arctic, or the Arctic, has the greatest ice extent in 11 years. Well, Al Gore said it was going to be gone. It's not. Now, the graphic also shows, here we are, November 18th, the black line. That is very close to the green line right here, which is the ice extent during the period 2000 to 2009. So you can see we're recovering. We're almost back to the period of 20 years ago, getting very close to it. So Al Gore, I'm sorry, but ice is not gone. It's actually increasing. And one more graphic on the ice. This is the Arctic ice extent also. And I do have sources where you can actually look up the data yourself. Right now, this is November 16th, and the gray line is the period 1981 through 2010, the mean, and we're starting to approach that. So there's 3 graphics showing the ice is becoming more extensive. Then also hitting the news back in 2019, we have the United States Congresswoman said the world will end in 12 years, in 2031. We're going to just burn up and the world will be gone. And how did that work out? Antarctica, winter of 2021, coldest on record. Doesn't sound like it's burning up to me. The high Arctic in 2022 and 2023. First, let me show what the graphic is. The blue line is the normal temperatures, average temperatures during the period 1958 to 2002. That was a cold period. That's the normal, the blue line. The orange line is the current temperatures, or the temperatures during the past, right now, this year. But what it showed was in the year 2022 and 2023, that's 2 years in a row, they've had the coldest spring and summer on record in the high Arctic. And I have it shaded in blue. This is beginning in April, spring, and ending in mid to late August, ending of their summer. And you can see the orange line is all below normal temperatures. 2 years in a row. I looked at all the temperatures going back to 1958. It has not happened even once during that period. So this is showing the high Arctic is cooling down. And what's going to cool down next? The mid-Arctic. What's next? The mid-latitudes. And this story just came out on the 14th of November of this year, 2023. World is warmer than any time in recorded history, and possibly in the past 125,000 years. This was put out by Climate Central and also the 5th National Climate Assessment. That's the U.S., United States Global Change Research Program. So they say warmest, this year is the warmest of any time in history in possibly 125,000 years. Well, the thing is, history only goes back to 1880 on recorded history. That's it, 1880. And I'm going to show you another issue on this also in the upcoming slides here. Temperature, actual recording of temperature by instruments was not available prior to 1980. And since then, prior to that, we had 32 global warming cycles. So this is not true. And another thing to look at is they say this is going to be the warmest year on record. Well, it's true. This report went right up through October. It's true. Through October of this year, it has been extremely warm. Warmest since 1880. However, everyone across the mid-latitudes of the United States into Europe and Asia has probably noticed that the end of October and November, in a lot of these areas, it's been colder than normal or right around normal. This report is going to have a hard time verifying being the warmest on record because we are cooling down. And this is what they're showing, warmest on record, and will continue warming. But one thing we're going to talk about is they use all the water around the world, also for temperatures. We never did that prior to satellites, really. And they say this is the climate average right now. Oceans and land areas, the red and light red, are above normal temperatures, and they say it's going to continue that way right through 2015 and beyond. Will this really happen? as they record global temperatures, what we call anomalies above or below normal temperature with satellite, it incorporates land areas, which is only 29% of the Earth's surface. Oceans are 71% of the Earth's surface. So they're including the oceans into recording of the Earth's temperature. And true, the oceans are very warm right now. You can see the oceans, the red, orange, and yellow are all above normal water temperatures. In the North Pacific, South Pacific, Atlantic, South Pacific, they're all very, very, very warm in the Indian Ocean. And one thing, you look at this really warm band from Africa, South America, westward, very, very hot, warm area. Well, we're going to look at all of this. Now, this whole area is included into saying, well, this is the world's temperature. Right now, we are having what we call an El Nino. When that occurs, South America is right here where my cursor is, on the right-hand side of the globe. When that occurs, the ocean water along the equator becomes very warm, way above normal water temperatures, and bands all the way across the Pacific. That's an El Nino. When we go to a La Nina, which is the opposite, the water cools down. All of a sudden, the blue, this is all cold water, a La Nina. And so we're in a El Nino right now, very warm. And that's the El Nino across there. Well, the El Nino is going to end around April 2024. So late 2024 through 2026. So it's going to cool down. Now, the Pacific Ocean has what we call the PDO, which is Pacific Oscillation. This is going back 500 years, back to 1500 AD. Reconstruction of water temperatures in the Pacific. And what we see is warm and cool cycles, warm and cool cycles, warm and cool cycles. Warm cycles last about 40 years. And here we are over on the right-hand side. We've been in the warm cycle for 42 years. The Pacific Ocean, when the El Nino ends in 2024, April 2024, the Pacific, most of the Pacific will be going into a cool phase cycle for the next probably 30 to 40 years anyway. So, in late 2024, ignore that 23, in late 2024, the equator area is going to be probably cooler than normal. And then the Pacific phase that's coming in, it's going to cool down much of the rest of the Pacific and the Indian Ocean. So we're going to see a big change if we're adding this into the world temperatures. Then we have the Atlantic Ocean, also has cool phases and warm phases. Atlantic Ocean, very warm phase in the late 1800s. Then it cooled down below normal temperatures, the blue. Then it warmed up again, 1927 through about 1960. Then it cooled down, and then we entered the warm phase again around 1997. Well, NOAA, the National Oceanic and Atmospheric Administration in the United States, uses a 100-year average for water temperatures. I just blocked off the 100 years that they use. So they use 2 cool cycles, 1 warm cycle. They're ignoring the warm cycle in the late 1800s and ignoring the warm cycle now. So what they're doing is taking average during 2 cool cycles. There is the what they take right there. So what they're doing is 26 years of cool, 39 years of cool, and only 33 years of warm. So when they take the average of the Atlantic Ocean, their figures are going to show that the normal is colder than a long-term average by leaving out the other 2 time periods. So that's even going to hurt more when the ocean starts cooling down, because the Atlantic is going to go into its cool phase probably around 2034, and it'll last up through about 2074. So you're going to have the Atlantic in the cool phase. So what I'm trying to show here is from starting sometime next year, but Pacific and the Indian Ocean cool down, and then in the by the mid 2030s, the Atlantic Ocean will be below normal temperatures also. So you add these in, and if the IPCC and NOAA figures out their world temperatures as they are today, all of a sudden, it's not going to work for them. They're going to have to change their averages. So this is going to be skewing the science, is what it is. So are destructive hurricanes caused by climate change? We're hearing this everywhere in the news. Every flood, every tornado, every snowstorm, every heat wave. It's caused by global warming. Well, let's take a look at hurricane landfalls in the United States. This is a 7-year period from 2009 to 2015. Actually, a 6-year period. And what it shows is we only had 3 hurricane landfalls, not many. Now, what the media is looking at, or what they will be looking at after they see what I'm showing, is we have 3 warm cycles in the Atlantic Ocean. Late 1800s, I showed you that. Second one peaked out in 1950. We had a lot of hurricanes during the 1940s, early 50s. And then we warmed up again, and the ocean is at its peak warmth right now. So what do we see on that? The blue line is hurricane landfalls for the United States. We saw the peak in I just put on with the red line the Atlantic Ocean water temperatures and warmth. The hurricanes peaked as water temperatures peaked. Hurricane landfalls decreased when the ocean cooled down. Then we had peak hurricane landfalls during the warm ocean period in the 1927 to about 55 or so. Then it cooled down, and then when we warmed up again, we're all of a sudden getting a lot of hurricanes. This is not global warming. This is climate change cycles of the oceans. Remember, I showed prior to 2016, 6-7 year period, we only had hurricane landfalls. This is a 3-year period, 2020 to 2023. That's how many hurricane landfalls we had, a lot more than 3. This is due to the cyclical warm ocean waters. I, here at Global Weather Oscillations, put out hurricane landfall forecasts 6 months before the season begins, or 6 months before the landfalls. And I predicted every single one of these based on natural cycles. So that's what we have now, and the warm ocean is going to continue for several more years before it cools down. So coming from 2024 through 2032 in the yellow lines, fill in, we're going to have at least 12 more hurricane landfalls. And this is natural. This is a natural cycle. It is not global warming. Sea level rise. Here we are, sea level. Here's the 2050 sign. That's what they say is going to happen by 2050. This is NOAA and the IPCC. Says oceans additional rise 10 to 27 inches, 0.2 to 1 meter. A coastal flood disaster. This is what they're saying with global warming continuing. But we know global warming is not going to continue. So we're going to adjust this forecast for you on my next podcast. Now, let's get to the reminder that also that natural disasters like what I just showed you and the hurricanes, blizzards of snow, flooding, cold waves, heat waves, they occur during all global warming and global cooling cycles. You can't blame it on, this is just global warming. No, these are cycles because we have global warming, global cooling cycles. So where does political science come from? And this is what I've been showing you, and a lot of this is political science, where they've been forecasting the ice to be gone in the Arctic. World temperatures are going to continue warming. Major disasters from heat. Where do the people in political science, where do they get the political science from? And I call this political science, not real science. Climate change grants. They have become bread and butter for universities and colleges around the world since 1995. And the red flag, we need to change it. 90% of the scientists receiving grant money say that climate change is human-induced. And why do they say that? They're getting grant money. So, of course, they're going to say it's induced because this is where they're getting the money for research. Climate change research grants are only awarded under certain conditions. When governments or companies put out a grant for a university to bid on, the grant pretty much specifies what they're looking for. This is also in the medical world or even the food world. If you can't come up with the findings that they're looking for, you're not going to get the grant. Just about all grants from 1995 up until present are awarded in such a way that whoever takes the grant, their findings must have a connection between human activity and burning fossil fuel. And I've learned this from retired heads of departments have told me this. If their research division talks about natural cycles, they could actually lose grants or not get grants. They have to toe the rope and do what the grants say. And this is about the only grants we've had. And to get published in a science journal, researchers must show specific results to get published, connecting the event weather disaster to fossil fuel, global warming, or human activity. If they don't do that, they're not going to get published. And there's almost no grant money available for natural cycle research. And there's a story in the paper that came up back in October, I believe there was a researcher. He was trying to get his scientific research published in a journal. It was about the Hawaiian fires. And he indicated he had to leave out certain aspects to get published. Certain aspects that it wasn't climate change. So he left it out and it got published. So proven science. Let's go over to proven science now. We've talked so much about the political science. It's time to go to the real science. The Milankovitch cycles and ClimatePulse cycles. Historical and future climate change cycles. Well, this is where we are today. We're 6,000 years off of coming out of the glacial period. And as the Earth goes around the sun, it is an elliptical path, but you can see it's not really extensive one. And we're about 8,000 years off of the peak of the global warming cycle over here on the right. So we're starting to actually come out of this. When you go into a glacial cycle or start going into it, what happens is the Earth's path around the sun becomes more elliptical and it's further away from the sun. More elliptical. That's an ice age. And during the period we have right now, the closest approach to the sun is in January, and during the ice age, it's in July. So we have big changes in the tilt of the Earth, also changes on a 41,000 year cycle. And that's part of the glacial period aspect is the Earth tilts enough so that the Arctic and Antarctic receive less solar radiation. So this is what it looks like on the cycles, the end result. About every 120,000 years or so, this is a interglacial warm period. This is back about 450 or 425,000 years ago. Then you can see it doesn't last that long. Then you go into a deep, long glacial period. And I'm kind of saying that the Earth goes to sleep for a while. Then it warms up again. Big, long glacial period warms up about every 120,000 years. Here we are over on the right. Came out of the glacial period about 8,000 years ago, and we're supposed to be very warm. This is a cycle. We're supposed to be warm. And the carbon dioxide also increases. This is back 425, 50,000 years ago. Temperature comes up. Carbon dioxide comes up a few thousand years or several hundred years after the temperature rises, because it's the colder oceans. Well, I'll show you that in a second here. As the temperature peaks, carbon dioxide peaks a little bit later, holds on. You can see the carbon dioxide is still high with temperature going down. As the world cools down and the oceans cool down, the colder oceans absorb all the carbon dioxide or a lot of the carbon dioxide, then release it again on the next glacial period. And on this one, about 338,000 years ago, you can see the temperature peaked. Look at that. Carbon dioxide didn't peak for about 7,000 to 8,000 years later, a long time after the peak temperature. And this is what we see in all the cycles. Then we come over on the right to where we are today. We came out of the glacial period 8,000 years ago. Got very warm like we're supposed to. Carbon dioxide up to 412 parts per million. This is recorded instruments. We never had recorded instruments on the other cycles. But it came up, and 8,000 years later, we'd expect carbon dioxide to peak. 8,000 years later, that's today. About 7,000 years later, that we're supposed to peak with carbon dioxide. Because here we are, we came out of the glacial period 8,000 years ago, got very, 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 very warm for 2,000 years. Cool down, warm, cool down. Here we are over on the right. 7,000 to 8,000 years after the peak temperature. We're supposed to be warm. This is another warm cycle, natural cycle. But the carbon dioxide is supposed to peak now. Is the rise in atmospheric carbon dioxide since 1850 caused by human activity, burning of fossil fuel? NOAA, United States government, National Oceanic and Atmospheric Administration says, yes, it's caused by human activity. The United Nations Intergovernmental Panel on Climate Change says the same thing. It's all due to human activity and fossil fuel. 100%, they say, rise since 1850 due to fossil fuel. However, it is not. It is 80% natural. That is research that I conducted. Scrabble et al. in a physics journal found the same thing, 80% natural, and the plant stomata, 80% natural. If you refer back to Tom Nelson, podcast number 64 that we performed, we go into detail on how these corrections were made. This is real science. It's also available on globalweathercycles.com. And just to give you a small look at it, the plant stomata research, this is what it shows is that the carbon dioxide in the atmosphere changes rapidly during the global warming and global cooling cycles. Had a global warming cycle back 800 AD, and the carbon dioxide was way up to 375 parts per million, whereas NOAA and IPCC says, no, it was about 290 parts per million. Then it goes down during global cooling cycles, up, down. These are all global warming cycles here. And this is the current one, plant stomata research, but this was a 2010, said 375 parts per million is what we should be, natural. And we're probably up closer to 390 parts per million natural now. And one really interesting thing is you take 1,000-year mean of a plant stomata and you come out to 301 parts per million. Sure. And remember, IPCC and NOAA says we've never been above 300 parts per million. That's because the ice core samples say we've only been up to 297 parts per million, but that's a mean taking over a course of maybe 3,000 to 5,000 years. But that's very close, 297 to 301, taking mean values. So the plant stomata readings are probably real, more than likely real. And we're supposed to be very high carbon dioxide naturally right now. And this can all be found, as I said, on Tom Nelson podcast interview number 64. And that's on YouTube, number 64, or globalweathercycles.com. And the sources, the plant stomata cells, you can stop this video whenever you want. That's the source for the plant stomatas. It's published, peer-reviewed. And the ice cores, that's on our podcast. And also the physics journal, the Ken Strabel et al., that was also published in a peer-reviewed physics journal. So this is all proven science. So by doing the corrections, this is what we show is the dashed line here is 300 parts per million. But the ice core samples say we've never been above 300 parts per million. And we're up to 418 now. But as we corrected the research, this is where the carbon dioxide on each interglacial warm period should be. Corrected value. And right now, 378 plus parts per million is all natural. And we're at 418 parts per million. So very little of it is due to fossil fuel. Let's take a look at shorter cycles, alternating cycles of the climate change cycles for global warming and global cooling. Remember, we talked about global warming begins in the Arctic and Antarctic as it warms up every 200 to 230 years. And then it warms up the mid-latitudes. This cycle peaks out pretty much during the last 35 years of the cycle. And if 35 years of the cycle, we're talking about 1990 warming up to right now, 2023. That's almost 35 years. So we are peaking right now. And then as we start cooling down, the Arctic, and I showed you the high Arctic, has been having record cold during the spring and summers the past couple of years. And that will spread down into the Arctic in the next year or two or three. And when that happens, the whole Arctic cools, and then it spreads down to the mid-latitudes. And this happens in the southern hemisphere also. And for the temperature to cool down, again, it'll peak out probably about 35 years after the onset of global cooling, because it just keeps cooling just like global warming kept warming up. So the coldest part of the global cooling will probably be more in the 2040s and 50s. And this is the reason for it, is the moon elliptical path around the Earth, the gravitational cycles. And when we have certain cycles that come, where normal cycles, gravitational pull on a full moon is about 30 to 40%. But when we have what we call a perigee syzygy, gravitational pull increases up to about 44 to 47%. So what I did is I tracked these very strong cycles, which come every 4 years, about 9 years, 18 years, out to 72 years, and 200 to 230 years. So I tracked these cycles, and this is what I found. Here is the global warming cycles. The global warming cycle, which peaked around 900 AD, the next one peaked about, ended 200 years later. The next one ended 240 years later. The next one 200 years later. Next one 230 years later. So notice these, every other one. This one is 200, 200. That's 240, 230. So if we're going every other cycle, this one should end about 200 years from there. And 200 years, well, the last global cooling cycle began in 1825. And the year 1825 had 200 years to it. We're up to 224 to 225. We're going into global cooling. Now, this is some research I did many years ago, taking the power structure that I was talking about, the very strong syzygy events of the Earth, Moon, Sun. And it was a power structure. The yellow line is the power structure of the gravitational cycle. The red line is global warming cycles. So what we see is we come down to the bottom of the gravitational cycle, strength of it. In 1290, we started a global cooling cycle, a global warming cycle, excuse me. This is global warming down here. That global warming cycle lasted about 99 years. And then when the gravitational cycle changed, we went into dramatic global cooling. The next cycle came down, just as we got to the bottom of it, global warming cycle began 1530, ended around 1605. That was about 75-year global warming cycle. And then cycle ended, went into deep global cooling. Then we came into global warming again. 1745, ended at 1843, that's a 92-year cycle. So what we're seeing is a 99-year cycle, 75-year cycle, 92-year cycle. And then we came into our current global warming cycle in about 1927. And you can see the gravitational cycle is ending right here, 2024. This is 93 years. 93, 92, 99. This is right on schedule. We're going into the global cooling. And this is the Maunder minimum of the sun. And that also joins up to some respect to the global warming, global cooling cycles. But I do believe it's the Earth, Moon, Sun interactions that have the biggest play in the short-term global warming, global cooling cycles. So there again, there's our 6 global warming, global cooling cycles, and we're heading into the global cooling cycles. And as we recap, we have had 6 global warming cycles during the past 1,200 years, not one, like what Mann et al. Showed back in 1998, not one global warming cycle with that hockey stick, but we have had 6 global warming cycles in 1,200 years. Past 8,000 years is probably 80. Climate change cycles, 80, not just one, but 80. So who are the real climate change deniers? Skewed political science. Thank you for joining me today, and thank you, Tom, for having me on.
I'm looking right now at the UAH temperature data since 1979, and there is this spike in the last few months that's higher than even the 1998 spike. Do you think that we've just hit the highest temperatures that we're going to see in that data set for the next decades?
I believe so. I believe this past summer and fall, we saw the peak and the ending of global warming. We were supposed to be very warm at the very end of it. And just because, I was showing you the high Arctic, but 2 years in a row, spring and summer is below normal temperatures. And the ice is increasing up there when it's political science says it should be decreasing, should be gone by now during the summer. But it wasn't. It was during the summer. This summer was about the 11th greatest is the greatest ice in 11 years. But it was supposed to have been ice-free, according to Al Gore. So yes, I believe it has peaked. And when we see the El Nino go away in April to May of 2024, when that goes away, that's going to change the ocean temperatures. And they're no longer going to be able to say it's the warmest year on record. They're done.
As you look at that graph, since 1979, it looks like sort of gradual warming of maybe 0.17 C per decade for 4 decades, something like that. Do you think we'll see a reversal of that over the next 4 decades where it goes back the other way? Or any predictions on that front?
On the sea surface?
This is a UAH satellite-based temperature of the global lower atmosphere.
That's all going to be starting to go down. Now, what I'm seeing is, and I talked to you earlier on it, is a good portion of the mid-latitudes had been below normal or near normal temperatures during the past 3 weeks, 3 to maybe 4 weeks, really. So this is showing the changes occurring now. And of particular is NOAA, National Weather Service, was forecasting a very mild winter across the Northeast and, most of the northern tier states, a very warm winter. And myself, I said, no, it's going to be cooler than it's been during the past 30 years or so across most of the United States and Europe. And it's starting to occur. Farmer's Almanac, which actually does a better job than NOAA, is total agreement with me. They're on base with it also. And we're seeing the changes. There's more ice. When you have more ice, more cold air can form. Then you have more snowfall in the north. Alaska, I should add this on. Fairbanks, Alaska started their winter just about on schedule this year, back a month ago, really. And Siberia started to get their snow. So things are coming on where we're getting the snow cover in the high latitudes. And that leads to colder air being available. And up at my summer cottage in Maine, typically, I grew up in northern Vermont, and typically our first dusting of snow would be around, during Thanksgiving week. Well, up in Maine, they've already had 2 dustings. They had one about a week and a half ago, and then they had another dusting yesterday, or this morning, really. So things are changing. Things are coming back to normal. And I'm looking for a cold, snowy winter for much of the Northeast.
Okay. And on a separate note, what do you have any predictions as to what's going to happen with the Keeling curve data for CO2? Whether that actually might show CO2 going down and over the upcoming decades, or do you think it'll continue to march up?
No, I believe it's going to go down. If we look at the plant stomata data, the carbon dioxide goes down during global cooling cycles. Now, we will be adding industrial CO2, but I believe it's going to be more of an offset by the global cooling. So that will actually bring down the carbon dioxide some. Now, as far as them spending these billions or trillions of dollars for carbon capture, and there's an article out just recently that they're starting to put money into start up some of these big plants to capture the carbon dioxide and store it in the North Sea. Well, you store it, and that's going to just be more carbon dioxide to be released on the next global warming cycle. But you don't have to spend all this money. It's going to go down naturally. And the carbon dioxide really is not hurting the environment. If we go back into historical data, plants are healthier during higher carbon dioxide. The whole Earth, really, I think overall, a little bit better also. We're actually getting sort of oxygen starved because we do not have enough carbon dioxide. Because the plant life brings in carbon dioxide, gives off oxygen. So if we have less carbon dioxide, they're going to give off less oxygen. And our oxygen levels are so much lower than they were 300 million years ago. And we could start getting into trouble on oxygen for animal life on Earth.
And then there is this whole narrative that we can look at the isotopes of CO2 and we can figure out that the additional CO2 since 1850, that humans put it up there because of the isotopes. Do you believe in that narrative?
Well, what happens is you can't use new ice anyway. On the ice core samples I showed you going back 500,000 years, you can't use the new ice, which is the first 5,000 years of the ice. It takes 5,000 years for the air bubbles to get trapped or locked into place in the ice. What happens if we go back to podcast number 97 that I did with you, showed, well, actually 64, showed that during the first 5,000 years, you lose an X amount of the carbon dioxide back into the atmosphere. So it's been reported in many, many journals that you can't use the new ice and compare it to the ice from the past or what have you, because it's going to have that new carbon dioxide in it that hasn't been released back into the atmosphere. So that's part of political science.
Did you want to talk about heat pumps at all?
Heat pumps are really, really good in the mid-latitudes, southern latitudes. Here in Florida, I have a heat pump. It's great for getting the chill out during the winter, great for air conditioning. Then I have a summer cottage up in Maine, way up near the Canadian border. It's great for air conditioning in the summer, where they're in the spring, summer, and fall. Great for getting the chill off in the morning in the spring and fall, and great for air conditioning in the summer. However, the heat pumps right now, most of them that are being put in place, turn off if you get down to 15 below zero. They are perfecting better ones, but can maybe get down to 20, 25 below zero. But right now, a lot of them installed will shut down at 15 below zero. Now, in the far northern latitudes, during cold winters, with the global cooling, if we go back to like we were in the 40s, 50s, and 60s, you're going to have your heat pump shut down quite frequently during the winter. It's 15 below zero is nothing really in the far northern areas. And I talked to the heat pump salesperson, and he agreed with me completely that this is not good in the northern latitudes because they're very inefficient once you get down below 0 degrees Fahrenheit. They have to work very hard. And up in the state of Maine, what they're doing, they're giving out grants to get people to put heat pumps in their homes. But part of the grant, if you want the grant money to help you out in the purchase, you have to take your oil furnace or a gas furnace out. And what they'll do is they'll put in, I guess, a little bit of baseboard heat. Now, if you did this across all the homes in the northern latitudes where it was all electric, the demand on the electrical grid during the real cold snaps would be so great, you're going to have brownouts or power outages. No backup heat. None at all. This could cause so much damage to a home, broken water pipes, people can die because they do not have heat. We have to think 2 or 3 times on this. What are we going to do? And right now, in a lot of states, if you do have a heat pump, we had an issue on ours on the air conditioning during summer, and I called up for an emergency service to come in because it was pretty hot and humid at that time. They do not have emergency services on the heat pumps. None of the dealers. So they won't come out on the weekend. So you'd have to wait until sometime during the week. So if you're in the middle of the winter and your heat pump breaks on you on a Friday, you could be without heat for several days. And, well, all your water pipes are frozen, broken. This is it's political science in this, where it sounds good, it looks good, but they have not thought through it. You need backup heat. You need alternative sources. We're just not quite there yet.
Any other points you'd like to make before we wrap this one up?
We're definitely going into a global cooling cycle. That's very definite. We definitely just saw the peak of the heating cycle, the warming cycle. The peak is here this year in 2023, and goodbye.
All right. Thank you very much, Dr. David Dilley. I appreciate you taking the time, and we'll talk to you next time.
Okay. Thank you very much, Tom.